Right. Von Neumann, our standard CPU architecture that we've looked at with the fetch execute cycle. State the register in which the arithmetical logic unit stores its results. Now I think nearly everybody put accumulator. The mark scheme actually did say accept ACC, but try and write out the names in full. Okay. The accumulator is the temporary area for results from calculations. Now, for B, it says tick the stage of the fetch, decode, execute cycle in which the accumulator would receive a value from the arithmetic and logic unit. Right, the fetch bit is working out what the instruction is, so it can't be that. The decode bit, that's where you might need to bring additional things. Okay, now it did say in part A, stores the results. You can only store results once you've executed an instruction. Okay, there is nothing to do until the instruction has been carried out and you've got an answer, whether it was subtraction or a comparison or something. So it must be execute. Okay, right, then we had to do a dreaded little man computer question. Right, it says write an assembly program using Little Man Computer, which repeatedly, obviously that's important, asks for a number until 3 is entered. When 3 is entered, the program should stop. Right, the key thing you've got to do when you're doing Little Man Computer, labels for addresses. So if you need to branch to somebody, somewhere, it needs a label to go to. If you want to put some data, which we're going to have some data here because we want to know if it's 3, that needs to be after your halt instruction. Right, if you couldn't remember anything, you could have got a mark for writing that. And there's only 3. So to get input. Right, I'm going to repeatedly ask for input. So I'm going to put a label here, and I'm going to call it loop. So that statement, I'm going to label as loop. Right, in order, I don't have to store it. A lot of people were storing things. It didn't ask us to store anything. It just said, just keep checking to see if a number's 3. In order to check that a number is 3, the only thing we can do is do a subtraction. So if we subtract 3 from a number, if it's 3, the answer will be 0. Okay, so I'm going to subtract 3. We don't have constants in Little Man Computer. That's the thing we've got to try and get in our head. So I'll need a memory location with a 3 in it. I don't know where that's going to be yet. Okay, but I know that I'm going to put that 3 at that location. I'm going to write the rest of the code first. Right, if when I subtract 3 I end up with 0, I want to stop. So I'm going to say branch 0 to end. Don't know where end is yet, so I'm just going to put the label that I'll use to mark it. Right, if it wasn't 0, I want them to input again. So if I do not branch to the end, I want to go back to my loop. So I say, right, okay, jump back up to the root. If you want to do a little bit of annotation for yourself, that's what we're implementing. You're just saying, right, go back up to there. Now that I've got to that, I can see where the end of my code is. So I'm going to put a halt, and I'm going to label this as end. That's where I want it to stop. Now I've put the halt in, I can see where I can put my data. So my 3 can go down here. That 3. That's it. So that's the bit that jumps to the end. That branch. You must never put DATs at the start of your program. If you do that, the CPU is going to execute the code. Whatever that data represents. Okay? So we put the data after the code so that we don't try and execute the data. If you don't put a halt, you'll still try and execute the data. Okay? The Little Man Computer problems are generally simple. They'll generally be loops. They'll generally involve subtraction. Because we didn't need to store it, it simplified it a little bit as well. Practice Little Man Computer, that's all that is.